In this video, I will show how to use the optimization idea in a business-related scenario where profit, cost, and revenue functions are given. So in this case, we have not the revenue, but the price function and the cost function. So the total revenue function, as we know it, is the price multiplied by the units sold. So if the price is 150 minus half x, then the revenue will be 150 minus 0.5x times x. Now the total profit can be found by taking away the cost from the revenue. So if my revenue is 150x, I'm going to distribute this over here. 150x minus half of x squared, then taking away taking away the cost from it will give us the following function. And taking away 0.25 from 0.5 will just give me negative 0.75 x squared. So this is my profit function. Now the question was, how many suits must the company produce and sell in order to maximize the profit? So if I'm trying to find the minimum and maximum of a profit function, that means I have to find the derivative. So let's start by differentiating the profit function. So derivative of the profit will be 150 minus 0.75 times 2x, which can be distributed, or not distributed but multiplied, and we can factor out 1.5, or we can factor out negative 1.5 to get the following expression in factored form. And now to find the critical values, we set it equal to 0 or find the values where the function is not defined. Since it's a polynomial, it's defined everywhere, so we don't have to worry about that. But the critical value is x equals 100, because this is where the derivative is equal to 0. Next, we draw the sign chart for the derivative of the function. Because it has negative, it's going to be negative sign in the front, it's going to be negative to the right of 100 and positive to the left. That means the profit function will be increasing to the left of 100 and decreasing to the right of 100, meaning at 100 we're going to have a relative max. Since the function, from the way it looks like on the sign chart, doesn't increase any further, we may also conclude that at 100 we're going to have the absolute max. Alternatively, we could have determined this whether this is max or mean by doing the second derivative test. So the second derivative of this function is equal to negative 1.5, which is always negative. That means the function is always concave down. That means if there is a relative extrema, it has to be relative max. Anyway, so the answer to the question, what is the maximum profit, is P of 100. And the answer to the question, what price per suit must be charged in order to maximize the profit, is $100. So the only thing is left is to evaluate P at 100. So P at 100 will be 150 times 100 minus 0.75 times 100 squared minus 4,000. So we have 15,000 minus, so here we have 10,000 times 75, it's 7,500. So we have 15,000 minus 1150, which is $3,500. So the maximum profit is $3,500, and the price that we have to charge to obtain that profit is $100 per suit.